Hi, I'm Jun. I'm from DKM2A and the number matrix is 09 DKM21F1052.
Hi, my name is SRIRAM. My metric number is 09 DKM21F1067.
Hello everyone, I'm Sharvin. I'm from DKM2A. My matrix number is 09 DKM21F1072. Today I would like to present about topic integration and also show some solutions by calculating the graph area. First of all, what is application of integration? In mathematics, the process of integration is used to compute complex area related problems. With the application of the integration, solving area related problems, whether they are curved or curve between lines, can be done easily. Concept of application of integration. Basically, the calculations have been computed for ages. Both differentiation and integration have important role in this matter. Application of integration is essentially useful for engineering, science and mathematics. The major application of integration is done for the calculation of areas that cannot be solved by any other means. Is integration important for engineering? Several physical applications of the definite integral are common in engineering and physics. Definite integrals can be used to determine the mass of an object if its density function is known. Definite integrals can also be used to calculate the force exerted of an object submerged in a liquid.
What is integral? The application of integration is used to find out the integrals. The process of finding out the integrals can be termed as integration. When defining an integral, it also forms a function deriving another given function. The application of integration is important as it is used to find out the area of the region or volume of an object, whether it is a two-dimensional plane or in a three-dimensional surface. When finding out an integral where the function is integrated with respect to the variable x, then that means that the area between the curve and the x-axis, another name of the integrals, is antiderivative. As the process of finding out an integral is exactly the opposite of finding out a derivative. There are two types of integrals. In application of integration, different types of integral can be derived. The main two categories in which the integrals are divided are known as definite integrals and indefinite integrals. Definite integrals is the process of integration that takes place between two fixed limits or intervals. This means that the addition takes place between two fixed points only. These 2 points are known as the upper limits and the lower limit respectively. Alternatively, definite integrals can be also termed as Riemann integrals. It is integrate AB fx dx and integrate AB fx dx. Here, the fx is the function that needs to be integrated, and a and b are the lower limit and the upper limit of the integral respectively. The second is indefinite integrals. The term indefinite integrals means finding out the integrals of a function which does not have any lower or upper limits, or whose limits are not defined. Generally, represent an indefinite integrals as integrate fx dx equals to fx plus c, or integrate fx dx equals to fx plus c. Here, the term c denotes as a constant value. It comes after the process of integration is complete. This is a legit addition of term, as if needed to derive the result, the constant term c will become 0 on differentiation, making the function same as the one which was integrated. So we got the formula in the right side. This is integrate fx dx equals to fx plus c. What is the practical application of integrals? With the application of integrals, there are various practical applications on which this process can be applied. In mathematics, the application of integration is used to find out the area that lies under any curves. The average value that is represented by a curve, an area that lies between any two curves, and to find out the centroid of an object that has curve on its sides. Different types of logarithmic functions and exponential functions cannot be estimated in terms of area without the application of integration as well. The same goes for hyperbolic functions, which are solely based on integrable methods that can be solve such related problems. In physics, the application of integration is useful for finding out the center of mass or the center of gravity of an object. When an artificial satellite is placed on the orbit, then the satellite's trajectory and velocity can be found out with the application of integration. The thrust of an object can be calculated with the application of integration too. Similarly, the momentum and mass of objects, whether moving or stationary, can be found out with the application of integration. In chemistry and biology, used to study the rate of growth and decay in certain substances if compounds with the help of application integration. This has a special rate in estimating a half-life of harmful radioactive substance or finding out the duration of long-last fossil figures.
Now let's see one sample question of integration. The question is, the diagram shows part of the curve y equals to 3 times with in bracket x square minus 4 and a straight line y equals to 2x plus 9. The question tells us to find the coordinate of point K and point P and also the area of shaded region. First, to find the point K, we have to see the diagram carefully. In the diagram, at point K, we know that the x value is 0. So we have to substitute the value of x with 0 in the equation y equals to 2x plus 9. So we will write y equals to 2 times 0 plus 9. So for the value of y, we will get 9. Since the x value of coordinate k is 0, we will get 0, 9 for the coordinate of k. Then we can find the coordinate of p. For coordinate of p, at point p, the y value is 0. So we can substitute the value of y with 0 in the equation y equals to 3 in bracket x square minus 4. So we will write y equals to 3x square minus 12 because we have to expand the equation. So 0 equals to 3x square minus 12, and we can factorize this and we will get x minus 2 times with x plus 2 equals to 0, and we will get two value for the x value which is 2 and negative 2. If we see this graph, we know that the x value must be in positive, so we will only take 2. Then the coordinate of p is 2, 0.
Find the area of the shaded region. So we can see the graph up there, and based on that, the equation of the graph is y is equals to x times 1 minus x times x minus 3. Whenever we expand it, it's equals to 4x square minus x cubed and minus 3x. Next, we write it in the formula of area. Area A is equals to integral 1 4x square minus x cubed minus 3x dx. Whenever we integrate it, it's 4x cubed per 3 minus x power 4 per 4 minus 3x square per 2 whenever we, and then we replace the x with 3 and 1, and we calculate it. The answer is 8 per 3 square units.
So the third question for me is we need to sketch the graph of the curve y is equals to x squared minus 3x in the straight line y equals to. Then we need to find out the area enclosed between them. So the first thing is to take it out our information. The first thing is going to take it out the y equals to x squared minus 3x and the y minus y equals 2. Okay, we're going to take it y equals to y, so x squared minus 3x equals 2. So we're going to take the 2 in front, so it will be x squared minus 3x minus 2 equals 0. So we're going to take it equation qn using a calculator, scientific calculator. Okay, we know that the x1 is 3.56 and the x2 is negative 0.56. Okay, this is both of the x is the interaction of the function. Okay, now we got the x1 and x2, so we're gonna take a digit into the formula. A equals to integrate dA fx dx. So we're gonna take it in, we're gonna move in the digit into the formula. Okay, so it will be integrate 3.56 and negative 0.56 x squared minus 3x minus 2 dx. So we're going to differentiate the equation inside. Okay, so we're gonna, the x squared will become x cubed per 3. So in 3x it will be 3x squared per 2, and lastly the 2 will be 2x. And after that we're gonna fill in the x with the 3.56 and negative 0.56. Okay, so for the 3.56 we got the digit of negative 11.09. when the second, for the x equals to negative 0.56, we got the answer is 0.59, and total it is negative 11.6x unit square. This is the graph. The function with the u shape is the y equals to x squared minus 3x, while the straight line is y equals 2. Okay, so the shaded region is the area we need to find. So it is 11.68 unit square.
Finally, the conclusion: with integration and differentiation as mathematical techniques, I have been able to reach the solution of the different methods used. Each of the methods brings a simple and clear way, thus can be used for practical data. Furthermore, with tablets and figure, I have been able and compare the actual data with the predicted data. The analyzing of the different countries that are less developed has given an overview of how overpopulation will cause several problems. For example, instability showing the country's development, the viscous poverty circle, pollution and environmental degradation. Using techniques above, I have been able to predict population sizes with and without family planning. Therefore, it will be true if I say that other developing and undeveloped countries deserve to emphasize on the implementation of the family planning rule in order to reduce the negative impact of massive population that has affected our world. Thank you.